Look closely at the floor of a healthy bioactive terrarium, and you'll find a swarming, hyper-efficient sanitation department at work. These are dairy cow isopods, or Porcellio laevis. In a bioactive setup, they act as the primary defense mechanism between your pet reptile and a floor full of decaying waste. But there's a biological catch that trips up many keepers. These animals are actually terrestrial crustaceans, not insects. Keeping them alive requires managing the specific physiological needs of an animal that, despite living on land, still carries the respiratory traits of its marine ancestors. Because of that ancestry, dairy cow isopods don't have lungs. Instead, they breathe through specialized lung-like gills located underneath their bodies, and those gills only function when they are surrounded by moisture. If the soil or the ambient air in their enclosure dries out, the gills seize out. The isopods will suffocate in the open air. To harness their cleaning power, you have to engineer a microclimate that maintains high moisture levels right inside the enclosure. Trapping that kind of moisture requires the right foundation. For a starter colony, a 10-gallon enclosure provides enough spatial volume, though you'll need 20 gallons or more as the group expands. The floor of that enclosure needs a specific mixture of coconut fiber, decaying leaf litter, and bioactive soil. It needs to be layered at least 2 inches deep to give them enough room to burrow and escape the drier surface air. This deep soil helps lock the enclosure's humidity into the required 70 to 90% range. It also helps stabilize the ambient temperature, which needs to sit between 65 and 80 degrees Fahrenheit. When layered correctly, this substrate acts as a mechanical sponge, sustaining their gills and preventing colony collapse. Once their breathing is secured, they require a regular diet of fruit scraps, vegetable waste, and dense oak leaves. But a purely vegetable diet ignores a major vulnerability of crustacean biology. Their exoskeletons require a constant intake of calcium. You must provide that calcium by adding supplements like cuttlebone or crushed eggshells directly into the habitat. Without it, the molting process fails. An isopod will experience an incomplete molt, become trapped inside its own shedding exoskeleton, and die. Providing cuttlebone ensures the colony has the structural material needed to successfully molt and grow. When the moisture and calcium levels match their evolutionary needs, the colony begins to reproduce rapidly. Dairy cow isopods are hermaphroditic, possessing both reproductive organs, though they still pair up with a partner to exchange genetic material. A fertilized female carries her eggs inside a brood pouch for about 3 months before the young hatch. The offspring reach maturity at 6 months, growing to nearly half an inch long, with a total lifespan of roughly 2 years. Once fully established, the isopod colony functions as a completely self-sustaining cycle that processes waste and aerates the soil automatically. If the environment is managed perfectly, the primary threat to the colony shifts from environmental stress to overpopulation. Unchecked growth can eventually exhaust the habitat's resources, causing the microecosystem to fail under the weight of the population. Maintaining the balance requires manual intervention, such as moving individuals to other terrariums or introducing natural predators like springtails to manage the growth. By balancing the moisture, calcium, and population density, the keeper maintains a stable, functional environment that reflects the specific evolutionary history of these terrestrial crustaceans.